Hello, my name is ZhaoyanLi and my university ID is N13783135. And today we are going to make a report about system engineering, and this is my midterm report. And today my topic is Intro to Boeing 737 MAX, and this is a type of the plane that Boeing company has. Okay, I will going to have the 4 parts to have an introduction about this. The first part is the intro to system engineering, and it is about the definition of the system engineering. And the second part is the background of the plane, the 737 and the 737 MAX. And I will tell you why I choose this topic. And the third part is the concept development stage. And in this part, I will talk things about the need analysis and the concept exploration and the concept definition. And this is the requirements about the project. And in the fourth part is about the challenges, and there are many challenges in all the system engineering. So I will talk something about the challenges that a 737 plane have. And for the first part, we need to know that system engineering is an interdisciplinary approach and means to enable the realization of successful systems, and is very important in our daily life since our equipment and all the transportations or the tools need to be one of the system engineering, and also it's very complicated. The definition of a system is inherently applicable to different levels of aggregation of complex interacting elements. Every system may be regarded to be a subsystem of a higher level system, and every subsystem may itself be considered as a system. And there are 3 entities that constitute the media on which systems operate are information, material, and energy. Information is about the definition, the knowledge that every engineers and the designers need to know. And the second one is the material. Material is very important in all the system engineering, and it is updated day by day. And we know many engineers is devoted to improve the material to fit all the environments. And the third one, energy. And energy is all around our lives, which analyze the operation and movement of all active system components. And at the beginning of the system engineering, to make sure that each element is neither trivially, simply, or inordinately complex. This element should be selected by using the following: significance, singularity, and commonality. And these are 3 requirements that we need to know in the beginning. And also, for the system engineering, we need to know the structure of the complex systems. The complex system also has the hierarchy structure, and it consists of system, and below it has the subsystems and the components and subcomponents and the parts. All of these consists of the tools and the components together and to make it work. The term system that is commonly used does not correspond to a specific level of complexity. Systems may serve as parts of supersystems, and the subsystems may themselves be thought as systems. And first, let me introduce the background of the 737. And this plane is famous all around the world since many airline companies are used to this plane. This plane was first invented by the Wright brothers. Sorry, it's about plane. Plane was first invented. And the control system is a duck-like layout with forward cyclic and backwards run. By changing the size and the angle of the wings, and the pilots can control the airplane, eventually can increasing lift. And they use the principle as a system. For example, they divided the plane into 3 parts: main body structure, the wings, and the engine. With 3 parts working together and the right control of the pilot, they finally made it. That's the first time system engineering used in plane making. And the Boeing 737 is an American short to the medium-range jet and a narrow-body airline developed and manufactured by Boeing Company. Originally developed as a shorter, lower-cost twin engine airline derived from the 707 and 727. And this is a high-ceiling commercial jetliner. Also, it is a commercial aircraft that can divide into 5 parts. And for the MAX plane, and it is developed in the base of the Boeing 737, which added some new technology in it to accommodate with more people, such as updating the engines and adding the MCAS system, and I will tell you in detail in the next part. Moreover, it improved the engine and using less fuel than before. At the same time, it improved the software. Also, the system is very excellent at that time. And now we talk about the accident. And why I am interested in this topic is because the accidents of the MAX plane is caused many people's attention in the world, and you can see 2 accidents in the PowerPoint, and it's very amazing. And the third part is the concept development stage. And I will tell you in 3 parts. It's a need analysis, concept exploration, and concept definition. The first part is a need analysis, and I will tell you the plane from the Wright brothers. And the Wright brothers, when they developed the plane, and they need to lift the plane, and so they need to develop the structure, to design the engines, and to train the pilot, because they need to train them how to control their plane. And also it's very important to make the aircraft resist strong winds and reduce the damage. So they need to have many experiments in 3 parts: material, structure, and pilot. And they tried many materials, and they design their structures time by time. And for Boeing 737, and it's a very excellent plane in the world, and it can carry capacity of 100 people, and it can race up to 1,800 kilometers, and it's very effective at that time. And the next part is a concept exploration. And in this phase, they need to explore the best way to achieve the aim. We have said that Boeing 737 MAX, they need to accommodate more people, so they need to design a larger plane. So they explored the ways like changing the size of wings and increasing engines. They decided the way about using more advanced engines and change the designation of inside decoration. So they need the performance of engine and the structure of the wing. Compared with other planes, Boeing 737 MAX is used much cost and effective to develop engine. And you can see the pictures in the left part, and this is the engine of the Boeing 737 MAX. And also, the engine's type is a LEAP 1B, and it's an excellent designation at that time. And it can reduce the cabin noise. Meanwhile, the Boeing 737 MAX engine has increased its diameter and reduced its landing gear. And the third part is the concept definition part. Boeing designed for the Boeing 737 MAX series of MCAS system, and this is a breakout at that time because this system is very new and is very excellent at that time. But at this time, we can see that this system maybe have some troubles and some mistakes, since it caused many accidents. So we will want to see this system's update in the future. And also the designation of the wings is also very amazing. But maybe this things is also caused the accidents. And its equipment with the advanced technology wing ATW is this wing's name. Boeing thinks the new design will boost fuel efficiency by the extra 1.5%. And this is their aim to design this plane because they want to low down the fuel burning rate. Whereas the 737 MAX itself already 10 to 12% more fuel efficient. It was a really amazing breakout at that time. Also, it's very smart because it can accommodate more people, and the environment, the conditions in the plane, in the inside of the plane is also very excellent, and people can use Wi-Fi inside the plane. And you can see the left picture is the picture about the inside the MAX 737. And the challenges, we know that all the system engineering has the challenges. And today I will talk about the three main challenges to be faced. And except the dangerous, the huge honor of the 737, we need to know the problems of it. And as I said before, and it consists of three components like structure, material, and maintenance. So when engineers design the system engineering, they need to focus on the three parts. The first is about the structures. As I said before, the Wright brothers faced many problems about the structure because they need to design a structures that can make the plane lift stable. So today now our plane is also face the same question and problems. There are many bad environments and many bad weathers, and so these weathers maybe cause the troubles when plane is flying. And also I want to tell the second part about the maintenance. The maintenance is also very important, and I will say something about the maintenance which caused the Boeing 737's problems and accidents. And the materials, as I said before, they updated the engines and they updated the designation, the structure of the wings. Maybe these things also cause the accidents. So this is the challenges they faced. And in details, the maintenance is very important, and the Boeing 737 MAX faced many less of souvenirs. The Boeing 737 MAX didn't have any problems during its annual inspections. This is the report about their company, but we know that it's not true, it's not real, because the last of the souvenirs cause these problems, and the inspections report is also very bad at that time. However, in fact, in some news, after the accident, we found that Boeing 737 MAX has had hardware problems, and maybe it's a software problem, because I saw some news that people say that the Boeing company, in order to decrease the cost, they give the software design for some chip companies. So it's very dangerous. Some engineers have spotted the problems, but these problems were covered up. This is a news, so I don't know the true of whether it is true of this news, but it is also very important to face these challenges. And for many high precision large equipment like train, like car, like airplane, they all faced these problems. They all need to maintenance and to repair. It is a large cost for the company. And for Boeing 737 MAX design, and we know that it's a company that the Boeing company will need to pay a lot of money for the reparation. According to the news, the Boeing 737 MAX may cause the serious wear of parts due to insufficient lubricating oil. Besides the regular issues discussed before, the parts themselves are not well protected. Also, engineers also have to consider the cost and the effectiveness when it comes to maintenance. This too needs to be designed and determined during the conceptual exploration phase. Where maintenance costs need to be judged if components with high performance are vulnerable to damage. For many high-precision large equipment and instruments, they need to be fixed after some time. And this is about my report of the midterm. Thank you.